Yes. So today let us begin by solving a simple problem from NEST 2023 second shift. This is a classwork problem. Okay, I want you people to try this out. It says the equivalent capacitance between P and Q for the infinite series of capacitors shown in the figure is C by 2 root 3 plus 1, C by 3, 3C, C by 2 into root of 3 minus 1. The structure of this problem is very similar to the problems which we solve in current electricity, where instead of capacitors we have resistors, right? You must have seen the network of resistors also like this, right? Let's say this is P and this is Q, and then we have the whole network getting repeated. And because infinity plus any number is still considered as infinity, okay, what we can assume is the net resistance across PQ can also be considered this, and then you can find RPQ with that equation. Okay, so essentially the same thing needs to be done here. Please try that. I will give you 2-3 minutes to find the answer. Remember, for capacitance, for parallel the capacitance they get added, and for series we have to use that parallel resistance formula. Okay, start and tell me the answer. Yes, any updates on the answer? Yes. Shreyas, what happened? देवप्रिया आया क्या आंसर या नहीं आया? ओके, रोशन, अर्श, Okay, I'll wait till 7:10 and then I will explain.
Think it should be between A and B.
A and
A and B.
okay.
Sir, I'm getting D.
You're getting D. Okay. Okay, fine. It's 7:10. So let me explain the problem. The problem is simple. Let us suppose that the net capacitance between P and Q is X. Okay. So like the way we had drawn this figure for resistors, we can similarly draw a figure for this network of capacitors. Okay. The only change is instead of showing that grid, I will show one single capacitance whose value is X. That's it. Okay. So now if you look at the blue one and the black one, they are in parallel, correct? So this will be equivalent to what? This will be equivalent to C plus X. Okay. And if we now replace, okay, if we now replace that combination by a single capacitance, then these three capacitors will start acting in parallel, and there lies our answer. Okay. So how to handle it? 1 upon X equals 1 upon C top 1 upon C plus X here, plus 1 upon C. Now you are supposed to solve this equation to get X in terms of C, get C plus X to LHS, keep 1 upon C terms on RHS, take LCM, X will get cancelled, X into C plus X equals 2 by C, correct? C plus X minus X will be C. Now cross multiply, okay, cross multiply, so I will get 2x into C plus 2x into X, and this will be equal to C squared, so minus C squared equals 0. Now what will be the capacitance now? Okay, let us rewrite the terms in our standard order. Okay, so did you people get this quadratic equation? First of all, tell me that.
Yes, sir.
Yes.
Sir.
Now, Shreyas, when you say either A or D, I think you need to look deeper into the equation you got, because look here, the product of the roots is negative C squared by 2. Now, C squared cannot be negative, है ना? Which means the roots of this equation, there are two roots, one root positive, the other root will be negative, and you will reject the negative root. Got it? So now we can apply the formula. Minus b plus or minus root of b squared minus 4ac. Okay, so plus 8c squared upon 2a. Okay, so 4 is there, so negative c by 2 will come, plus or minus. This is 12c squared. 12c squared root will be 2 root 3c by 4. Correct? So this will go. We can take c by 2 common. Okay, we can take c by 2 common, and see, now I am not going to consider the negative root because we know that capacitance cannot be negative, isn't it? Capacitance cannot be negative, so c by 2 into bracket positive root 3 minus 1, and that is option D. Understood? Yes?
Yes, sir.
Okay. Now, for those people, I want to ask you who could not solve the problem, where did you face the issue? Like in which part of the solution? Please tell me. Was it right at the beginning, or was it in solving quadratic equation, or was it in finding the roots? Hmm?
I think for me it was at the beginning.
Okay. See, at the beginning,
Why do we
yeah, please continue.
why do we take the right side also to be x? We took PQ to be x, right?
Huh. So, what is the mathematical explanation to that would be, because there are infinitely many such capacitors here connected in the same pattern, right? If I take this out, okay, if I take this out and give this to you, you will say, okay, this will still be PQ, correct?
Okay, yeah.
So, mathematically we say infinity plus c is infinity, where c is a real number. Okay, and then we did that. Got it? So that's why at the beginning we discussed the same thing for resistors also. Maybe you people are familiar more with that resistors. Okay, fine. Alright, let's go to next MCQ. I hope there is no doubt in this MCQ. This was easy MCQ, but it was asked in NEST, so I included it here. Acha. Now let us go to the next MCQ. Sorry, this is a multiple select question. Okay, this is also from previous year, that is 23 first shift. The electrostatic potential in the region between two long coaxial cylinders of radii A and B is given by phi equal to alpha into ln r by alpha plus beta, where alpha and beta are constants. Here alpha is greater than 0 and r denotes the radial distance from the axis such that r is in between AB. Then the correct options are, or option is A. The charge per unit length on the inner cylinder is minus 2 pi epsilon naught alpha. Capacitance per unit length is ln B by A upon 2 pi epsilon naught. The charge density on the outer cylinder is negative epsilon naught alpha B squared by B squared. The electric field in the region between two cylinders is negative alpha by R cap. Okay, so let's now draw the figure for this particular arrangement. Let us say this is the larger radius cylinder, and let's say this is the inner one, the smaller one, and this is how the cylinders are. Okay, yes, so long means we can assume the length as infinite. Okay, so this is A, this is B. Now we are given the electric potential in the region between two coaxial cylinders, मतलब यहाँ पे. Okay, alright, now we can imagine it to be a planar situation now. Okay, so electrostatic potential is given. Okay, electrostatic potential is given alpha ln r by A plus beta. Okay. Now, tell me, can we find the field from potential? Do we know any formula for finding electric field from
E is
potential?
equal to negative dV by dr.
Correct.
Derivative same.
Correct. Electric field is actually negative of gradient of V. And for us now, the gradient is only going to involve one parameter, and that is R. तो निकालो और बताओ कितना आ रहा है. Okay, so negative alpha ln R's derivative will be 1 upon R. Okay, 1 upon R, and then we have to take, okay, see, look, A is a constant, so ln's derivative will be 0, beta's derivative will also be 0, and then we have to consider the sign here. Okay, so it will be R cap. Okay, now see, let's now try to argue whether R cap assignment, okay, R cap is the unit vector in this direction, okay, any radial direction is going to give us a different unit vector. Now let's try to argue like this. Is this R cap correct, or should we consider positive sign here? Okay, how can we argue for that? Look, please tell me, where is the potential greater? Is the potential greater at A, or is the potential greater at B?
So
Yeah.
potential is greater at B.
Phi B,
What's
let's
the
get.
potential?
एक मिनट निकालेंगे. Phi B. Phi B is equal to alpha ln B by A plus beta. Potential at A is beta. Yes, and because alpha is positive, they have given. Alpha is positive, they have given. So the potential is higher at B than A. Okay, so the potential is decreasing as we go inside. Okay, like this one. Now tell me, is the direction of electric field justified? If this is VB, okay,
Yes, sir.
हाँ, justified है. क्यों justified है?
It is in opposite direction, negative side.
Correct. So E bar must be from B to A, hence negative R cap is justified. Raise your hands if you have understood this. Okay. Fine, so option D is correct. है ना? Option D is correct. Now let us go to Gauss law. Okay, let us go to Gauss law and apply it for our cylinder. Okay, let us go to Gauss law. Now particularly this Gauss law is going to be at work to check whether option A is correct or not, because they want us to find charge per unit length. Okay, so let us assume that the charge per unit length on the inner cylinder is lambda. Okay, charge per unit length on the inner cylinder is lambda. So we consider a Gaussian surface. Okay, we consider a Gaussian surface. Let us say its radius is R. Okay, its radius is R. Let a cylindrical Gaussian surface है ना. तो अभी मैं वो ब्लैक कलर में दिखाऊंगा यहाँ पे. ignore that potential markings. Okay, better let me remove them right here. Yeah, okay. So this is what I intend to show. ये अभी हमारा गॉसियन सरफेस का क्रॉस सेक्शन होगा, ठीक है. Okay, so suppose its length is L. Okay, and if we apply Gauss law, what does Gauss law tell us? Surface integral of electric field is given by 1 upon epsilon naught into charge enclosed. Okay, got it? Everybody knows that this is Gauss law. Okay, now look, elementary area vector, okay, elementary area vector, it will be directed radially outwards. So dA bar will be dA r cap, है ना? dA bar will be dA r cap. And how about electric field? Electric field is negative alpha by r cap. So what does it mean? It means both electric field and dA bar, they are along r cap. Electric field is in the opposite direction, but that does not stop us from using the fact that r cap dot r cap is 1. Okay, r cap dot r cap is 1. So here is how we can handle the situation. Over the entire surface integral, entire surface of Gaussian surface, negative alpha by r cap dot dA r cap. Now please raise your hands if you have understood this. If you haven't, please ask me, I will explain it again. Okay, this is q net. Acha, okay, wait. Now for q net, can I write lambda L? I can, because lambda is linear charge density. We want total charge, so we must multiply it by the length of the cylinder that we consider. Okay, now look, what will be the elementary area dA? Can anybody tell me what would that area be? Yes?
So 2 pi r into length of cylinder.
Yes, we can say as a field at every point at a distance r is same, okay, as same, we can consider integral dA. Okay, so no need for integrating field with respect to that, because it is already there. So what are we going to get? Negative alpha by r cap dot r cap is 1, 2 pi r l is dA. Okay, this is this one. Okay, okay, L will go, so lambda will be how much? Lambda will be okay, RR will also go. Lambda will be negative 2 pi alpha epsilon naught. Okay, negative 2 pi alpha epsilon naught. Does it match with option A? Negative 2 pi alpha epsilon naught. It does. Okay, it does match with option A value, so A is correct. A is correct. Okay, now for B and D, B and C. Okay, left for B and C. How can we argue for B and C? Yes, any suggestions for B and C? Any ideas?
Yes, sir. We will use a formula of capacitance. C is equal to Q over B potential.
ओके फाइन, ग्रेट. सी के लिए ना, या बी के लिए? सॉरी, बी के लिए. गो अहेड.
Sir, we have been given charge and we have already find out charge and potential, so we'll substitute those values here.
ठीक है ना, डेल्टा वी तो निकाल सकते हैं ना. हाउ मच इज डेल्टा वी? इससे यूज कर सकते हैं. अल्फा एल एन बी बाय ए प्लस बीटा माइनस अल्फा एल एन ए बाय ए माइनस बीटा. ओके, ये आ गया पोटेंशियल डिफरेंस. क्यू कैसे निकालोगे अभी? Yes, yes, tell me. Go ahead, don't stop. Capacitance
Sir,
is...
we have already find out charge per
हाँ,
unit length. We'll
correct,
divide,
correct.
We'll multiply with the length of the selector.
Correct.
Find the total charge.
Yes. चार्ज पर यूनिट लेंथ है नेगेटिव 2 पाई अल्फा एप्सिलॉन नॉट. ओके, हमें कैपेसिटेंस पर यूनिट लेंथ ही चाहिए, है ना. सो इट विल बी 2 पाई अल्फा एप्सिलॉन नॉट. Okay, 2 pi alpha epsilon naught. Alpha will get cancelled. Alpha will get cancelled. So we will get 2 pi epsilon naught upon ln b by a. So b is not right. Is it clear?
Yeah.
Now see, for those who are finding this particular way a bit difficult, you can also use dimensions. We can dimensionally prove that B is incorrect. Do you want to try that on your own, or shall I do it here? इस ये डायमेंशनल भी हो सकता है बी का. कैसे होगा? लुक, डायमेंशंस ऑफ LHS, इट इज कैपेसिटेंस पर यूनिट लेंथ, है ना. अब देखो, कैपेसिटेंस का यूनिट क्या होगा? कूलम पर वोल्ट मीटर, है ना, because of the length. Now let us go to the quantity on the right hand side. ln b upon a तो dimensionless है, 2 pi epsilon नॉट है, मतलब अभी हमें सिर्फ 1 upon epsilon नॉट का डायमेंशन यूनिट चाहिए. Now for that we go back to Gauss law. Okay, we go back to Gauss law. Okay, now from Gauss law, is it possible for us to obtain the unit of 1 upon epsilon naught? Yes. How is it possible? सबसे पहले इलेक्ट्रिक फील्ड का लेते हैं. ओके, इलेक्ट्रिक फील्ड इज वोल्ट पर मीटर. अभी निकाला डेरिवेटिव, है ना, वोल्ट पर मीटर, दैट इज द यूनिट ऑफ इलेक्ट्रिक फील्ड. ओके, तो वोल्ट पर मीटर इसका हो गया. एरिया का कितना हो जाएगा? मीटर स्क्वायर्ड हो जाएगा. और अभी और एक बचा है, Q net is remaining. Q net will go in the denominator here, so it will be coulomb here. Okay, so meter squared, we will get rid of one of the 2 meters that are there in the numerator. That means RHS's unit is volt meter per coulomb. but actual capacitance per unit length unit is coulomb per voltmeter. So because they are dimensionally not equal, option B is not right. Okay, got it?
Yes, sir.
Okay, fine. So ऑप्शन बी नहीं है. अभी ऑप्शन सी का कैसे करेंगे?
When Q equals CV, charge capacitance per unit length times change in potential.
Okay. Now I have just one question here. Can we say that the capacitance, the charge on the outer capacitor will be positive, or no such claim is possible?
Yes, sir, positive. Since electric field is coming from positive to negative.
Yeah. I can say this. Okay. Field in is radially inverts. Okay, field in this is radially inverts. Therefore, outer cylinder must be positively charged. Okay, is that a safe statement to make, or can it have alternatives? Please tell me. What do you think? यहाँ पे फील्ड निकाला तो वो अंदर की तरफ आ रहा है ऐसे. So
Yes,
if we
it
can,
is
yes, okay, wait,
option C is incorrect.
incorrect because of the negative sign. But let's also think about the situation where they had not given that negative sign. Okay, negative sign की वजह से हम reject कर सकते हैं उसको. But suppose they had not given us that negative sign, how can we proceed? Okay, how can we proceed? So what can we assume for that, or what can we write for that? C is equal to Q by, correct.
Yes.
C is equal to Q by V. So Q equals CV. Okay. Now what is C that we have calculated? 2 pi epsilon naught upon ln b upon a. What is V that we have calculated? V is potential difference, alpha ln b upon a. Okay. Yeah, suppose this will be charge density itself. Right. Wait. Yeah, C by L is there. Okay, we have anyway calculated as C by L. C by L, yes. So maybe we need to multiply this by L. Yeah. So ln b upon a will go. So this will be L into 2 pi epsilon naught alpha. Of course, we should have got the same answer. Okay, so the linear charge density will be same, okay, for both inner and outer cylinders. But it looks like they don't want us to find that. They want us to find the charge density. Okay, that means charge per unit volume. Okay, charge per unit volume. Now look here how we can take that part into consideration. Charge per unit length is known to us. Okay, this is charge per unit length, but how much volume is that particular cylinder occupying? If we have a cylinder whose length is L, okay, if we have a cylinder like this, let's say outer cylinder, so radius is B, length is L, okay, how much volume is it occupying? Pi b square L, correct. तो अभी हम लोगों को इसको एरिया से डिवाइड करना पड़ेगा, है ना, दैट मीन्स पाई बी स्क्वायर. So what will be the answer? Pi will go. Pi will go 2 epsilon naught alpha by b squared. Yeah, okay. So they have negative sign there, so we need to rule that out. And we have got it as 2 epsilon naught alpha upon b squared. मतलब negative sign के बदले अगर 2 होता तो accept कर लेते. So C is also not right. Any doubts here in this question? We have used everything. We have used Gauss law. We have used the relationship between electric field and potential. We have used capacitance formula. Okay, and we have also used dimensions. Derivatives are also there. Okay? So if you have any queries, please ask me. Otherwise, I will go to next MCQ. No doubts? Okay. Okay, question 3. A horizontal straight wire of length A is placed perpendicular to a long current carrying straight vertical wire at a distance of 2A and lies in the same plane as shown in the figure. Both wires carry steady current I. The magnitude of the force on the horizontal wire due to vertical wire is, and we have got 4 options. Option B 0. In all other options we have got mu naught I squared upon pi, and they differ only in the constants. ठीक है, काफ़ी आसान प्रॉब्लम है. नेक्स्ट 23 से है ये शिफ्ट. ओके, ट्राई करना है क्या? डू यू वांट टू ट्राई दिस आउट?
Yes, sir.
Yes, I will. Do you want me to tell you the formula that you're supposed to use? बायोट सावर्ट क्यों निकाल रहे हो? बायोट सावर्ट तो फील्ड निकालने के लिए ना, ये फोर्स चाहिए हमें.
IL.
हाँ एग्जैक्टली, डी एफ
IL,
बार इज इक्वल टू
Lorentz force.
हाँ आई डी एन बार क्रॉस डी बार. ये पहला फार्मूला हो गया जो अभी यूज़ करोगे, है ना. फार्मूला नंबर 2, B due to infinitely long wire will be mu naught I upon 2 pi r. Okay, but use this only in the range 2a to 3. ये important है. Okay, 2a to 3. ठीक है, go for it. See what option you are getting. Okay, I'll give you 3 minutes for this till 7:45, and then we can discuss the solution.
Sir, option A.
Okay, Gaurav has got A. Others, there is still option A ही आ रहा है. ठीक है,
Option A.
option A correct. Great. So option A is indeed correct. Let me just write down the expression for the integral. ठीक है, net force will be equal to integral of, okay, now let's go to the limits. Okay, L going from 2a to 3a. अच्छा, अब देखो, I can take the magnitude, okay, because I know that for all of these smaller lengths here, dl 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 dl, the force will be directed upwards. Okay, सभी के लिए force upwards ही है ना? If you apply that rule, so now you need to take out your left hand. Okay, you need to take out your left hand, point the middle finger towards right along the direction of the current. Okay, and point the index finger towards the screen. That's why this blue cross is there, because of the way the current is flowing from bottom to top in this conductor, and the thumb will point upwards. ठीक है, तो force का सबका direction same ही है ना? So no need to worry about that. Let's now write down this I. dl is correct. I is there, dl is there, and now we need to go for B, which is mu naught I upon 2 pi L. Okay, I hope everybody got this. So it's mu naught I squared I into I upon 2 pi integral of 1 upon L with respect to L is ln L, so ln 3a minus ln 2a. Okay, ln 3a minus ln 2a is ln 3a upon 2a. A will get cancelled, and therefore the correct answer is option. Okay, now do you agree that this force is also going to produce a moment or a rotational effect on that smaller conductor? Yes?
Yes.
Okay, now also note that this force is not constant. Okay, please tell me whether the magnitude of the force is decreasing or increasing as we go from 2a to 3a. How is the force distribution?
It will increase.
It will, नहीं, मैं यही पूछ रहा हूँ, इस पॉइंट पे जो फोर्स है और इस पॉइंट पे जो फोर्स है, इनमें से कौन सा पॉइंट ज़्यादा फोर्स एक्सपीरियंस करेगा? लेफ्ट वाला? हाँ, एग्जैक्टली, बिकॉज इट इज़ इन अ रीजन वेयर द फील्ड इज स्ट्रॉन्गर. ओके, सो इसका मैग्नीट्यूड बड़ा होगा. करेक्ट. So if the question were instead of finding magnitude of the force, suppose the question were find the magnitude of moment. Find the magnitude of moment about vertical conductor. This is not magnetic moment, okay, this is just moment, okay, moment of force. So what would the expression for that be?
So 0.
नहीं, ज़ीरो कैसे हो गया? सभी पॉइंट्स पे वर्टिकल फोर्स है.
Yes sir, force times distance.
हाँ, करेक्ट.
Total.
यहाँ पर भी इंटीग्रल ही करना पड़ेगा, because like force, moment will also not be constant. Let's see. So L is going from 2a to 3a. Okay, force is there, I dl b, and now we must multiply this by L, है ना? We must multiply this by L because moment is force into perpendicular distance. Okay, why that? Because moment is force into perpendicular distance. ठीक है, so now it goes, okay, so the moment will be mu naught I squared by 2 pi a. Why a? 3a minus 2a. ठीक है. या तो सिर्फ फोर्स ही पूछेंगे ऐसा नहीं है. दे कैन ऑल्सो आस्क यू टू फाइंड द मोमेंट हियर. ठीक है. एनी इश्यूज, एनी डाउट हियर?
No, sir.
Okay. Now just extending this concept further. Okay, just extending this concept further. They might also ask you something like this. Okay. If I wish to place, okay, if I wish to place a mass, let us say at the midpoint. Okay, suppose I wish to place a mass at the midpoint here. What should the value of that mass be so that it will balance the clockwise moment due to this current? And in that case you can say mu naught I a squared by 2 pi will be balanced by mg into 5a by 2. है ना? Because if the mass is assumed to be m, what moment is it going to produce about this? This is 2a plus a by 2, so this will become 5a by 2. So that 5a by 2 needs to be multiplied by the force due to the weight of the mass of that object. So mg into that, and that can give you the mass. ठीक है, ये निकाल सकते. Got it? I mean, if they indeed want to raise the difficulty level, not exactly difficulty level, you just have to add up things and eventually you will get the final answer. Got it? Any issues with the question?
No, sir.
समझ गया ना? Okay. All right. Okay. Next. Same year, 23, fifth one. On moving charges and magnetism. This is now a problem based on magnetic moment. पहले जो किया था वो सिर्फ मोमेंट पर था, मतलब फोर्स इनटू डिस्टेंस वाला. अभी मैग्नेटिक मोमेंट है. ठीक है. करंट इनटू एरिया. An elastic conducting ring of mass m is extended radially with constant speed v in an uniform magnetic field of strength b, which is perpendicular to the plane of the ring. Take the resistance r of the ring to be a constant. The magnetic moment mu of the ring in terms of the instantaneous radius of the ring r is given by mu equal to k r to the power alpha, where k and alpha are constants. Then the value of alpha is 0.143. One very important thing. Okay, this mu is not permeability. Okay, this mu is not permeability. Okay, it is magnetic moment. ठीक है. Now, please tell me. Okay, please tell me. Why would that particular ring will have a magnetic moment? Okay, what will be the cause of the current? Any?
Sir, magnetic flux is changing.
Yes.
So current will be
Correct.
induced by
Correct.
Faraday
Correct.
induction.
करेक्ट. तो दोनों यहाँ पे मैग्नेटिक मोमेंट भी है और इलेक्ट्रोमैग्नेटिक इंडक्शन भी है. ठीक है. सो सपोज दिस इज द फील्ड. ओके, यूनिफॉर्म है, कोई भी डायरेक्शन ले सकते हैं, डजंट मैटर. सो लेट्स टेक क्रॉस. ओके, नाउ लुक हियर. सपोज दिस इज द radius r of the ring, conducting ring. Okay, what will be the flux associated with this? Okay, in magnitude can I say it is b pi r squared? Okay, b pi r squared. Now what will be the EMF induced? Lenz's law.
d phi v by dt.
Correct. Negative d phi b by dt, which will be b into 2 pi r into v, where v is the speed. है ना, चेंज रूल अप्लाई किया. पहले आर स्क्वायर का डेरिवेटिव निकाला 2 पाई आर, बट दैट वाज विद रिस्पेक्ट टू आर, उसको फिर से डी आर बाई डी टी से मल्टीप्लाई करना है. ओके, बाय चेन रूल डी आर बाई डी टी इज इक्वल टू वी एंड वी इज कॉन्स्टेंट, सो अगेन नो नीड टू मल्टीप्लाई बाय डी वी बाई डी. ठीक है, ओके फाइन. सो दिस इज इंड्यूस्ड ईएमएफ नाउ. Okay, induced EMF, and this induced EMF is now going to give us the current. Okay, induced current. नेगेटिव साइन इग्नोर करेंगे अभी, उसकी कोई ज़रूरत नहीं है. सिस्टम मॉडी. ओके, नाउ दिस इज इक्वल टू आई आर, करंट इंटू रेजिस्टेंस, सो इट विल बी 2 पाई आर वी बी. सो करंट इज इक्वल टू 2 pi r v b by r. Capital R is resistance, small r is radius. Okay, now what is moment? Magnetic moment. Current times area. Correct. 2 pi r v b by r, pi r squared. So 2 pi v b by r, pi squared, 2 pi squared Vb by r into r cubed. Okay, so now have we obtained the correct expression? Yes, we have. K भी आ गया, alpha भी आ गया. K is this and alpha is 3. Okay, alpha is 3. Option D. Raise your hands if you understood that. Okay, तो यार ये थोड़ा IIT लेवल का था, मिक्स्ड कॉन्सेप्ट्स थे लेकिन ज़्यादा मुश्किल नहीं था. Alright, one more on current electricity, this time from NEST 2022 second shift. In steady state, the charge in microcoulomb stored in the capacitor C equal to 2 microfarad in the circuit below is 6, 12, 18, 24. Try करना है?
Yes, sir.
Yes, करो try. I'll give you 5 minutes or 4 minutes. At 8 o'clock, we will. Oh, okay. 8181.
Yes.
Okay. So we've got an option. The option is B. Others also let me know what answers you are getting.
Option B, sir.
12 ही आ रहा है. वो बी डी का समझ तो नंबर बताओ कौन सा आ रहा है.
12, sir.
12 ही आ रहा है. करेक्ट. Others, what about you? ठीक है. I will now explain this problem. 12 is right. First thing is that we have to correctly interpret this. What does steady state mean? Steady state means di by dt is 0. Okay, di by dt is 0. So that basically means capacitor is neither charging nor discharging.
So could you also say that the capacitor at that moment is completely charged?
Yes, we can say that depending on what potential it has, okay, across the plates. So under steady state, what we can do is we can happily assume the current to be flowing like this. This is an open circuit now, okay, because the capacitor is okay. Now I'm deliberately showing it at many places just to emphasize on the fact that this branch doesn't have any current. Okay, now we can find the current by applying loop rule. We can find the current by applying the loop rule. Let us start with the battery of 12 volts. Positive 12 minus 8 I. अभी I को मैं कॉमन ले लूँगा. सभी रेजिस्टर्स में एक सेम ही करंट जा रहा है. 8 plus 3 plus 5. Now please tell me what will the convention be for this 4 volts? Is it assisting? It's not. Yeah, correct. Negative.
Sir, energy.
Correct. रेजिस्टेंसेस कर लिए तीनों. 16. सो बराबर 4 8. सो 8 माइनस 16I is equal to 0. तो करंट आ गया. Current is half amperes and it is flowing in the same direction as we had shown or assumed it to be. ठीक है. Now, okay, let me also show the loop. Sorry. So this is our blue loop now, the bigger one. Okay. Now to find the potential difference across this capacitor plates, because to find the charge we must know the V part. Okay, because C is equal to Q by V. Now I am going to consider this loop. Okay, this loop. This loop only. So again apply loop rule. Okay, but which loop now? The red one. Okay, so 12 volts minus 8 into 1 upon 2 or 1 upon 2 into 8 IR का part है. Okay, now we are entering this. Okay, tell me, will this 2 volts be considered positive or negative? Negative लेना चाहिए. Correct, negative minus 2. And let's say minus V, उसको ले लेंगे, V अभी लेते हैं. ठीक है, equals 0. Okay, so this is 4. So V will be 6 volts. So can we find the charge now? Yes. C is equal to Q by V. So Q must be Vc. V6 C2 एंड चार्ज भी माइक्रो कूलम में ही पूछा है तो माइक्रोफैरेड का वैसे ही लगेंगे. Charge is 12 microcoulombs. Yes, option B is correct. Okay, it was a pretty simple MCQ. Okay, but you had to understand that steady state means capacitor से कोई current नहीं जा रहा है, मतलब यहाँ पर भी नहीं, यहाँ पर भी नहीं. Okay, now do you remember there have been questions on the steady state networks in IISc aptitude test. वो cube वाला problem था जो हमने solve किया था. Remember that problem? This is in the same league as that, but the only thing is this is much simpler and the circuit shown is 2D circuit. Okay? At least the geometry. Alright, any other doubt in this? No doubts?
No, sir.
Okay. Let's continue. Okay. तो ये भी और एक प्रॉब्लम है, ये आसान है एक्चुअली. आई वॉन्ट यू पीपल टू ट्राई दिस. लेट्स रीड इट. ये नेक्स्ट टेंस है, ठीक है. अ नॉन कंडक्टिंग स्फीयर ऑफ रेडियस कैपिटल आर हैज़ अ पॉजिटिव चार्ज Q यूनिफॉर्मली डिस्ट्रीब्यूटेड ओवर इट्स एंटायर वॉल्यूम. अ स्मॉल कॉन्सेंट्रिक स्फेरिकल वॉल्यूम ऑफ रेडियस R लेस दैन कैपिटल R इज स्कूप्ड आउट ऑफ द स्फीयर. The magnitude of the electric field E at a point inside the body at a distance x from the center is k is 1/4 pi epsilon naught kq by x squared kq r cube upon x squared r cube kq by x squared x cubed minus r cubed upon r cubed and 0. कैसे करोगे? कुछ
Yes,
keywords है यहाँ पे. First is it is non-conducting, so the charge can remain wherever it is. They're saying uniformly distributed. Okay, they're saying uniformly distributed. Okay, मतलब charge density constant है. Okay, charge density is constant. Now we are actually removing some volume. Okay, we're actually removing some volume which is going to decrease the net charge on the on the sphere. Okay, but charge density is still going to remain the same for the original sphere and the annulus that we are going to get after we remove that. Okay, and then we need to find the magnitude of the electric field, so you can apply Gauss law. And there is one more thing that we must remember, and what is that? When we consider, okay, when we consider either gravitational field calculation problems or electric field calculation problems, okay, if we consider a sphere, okay, if we consider a sphere, okay, and if we are interested in calculating the field on this sphere, okay, the only thing that contributes is the charge or is the charge or the mass that is inside. Do you remember this?
Yes, sir. We'll apply Gauss law.
हाँ वो वही है basically. Okay, field here can be computed by considering inner charge because it is uniformly distributed. ठीक है? And secondly, that inner charge can be assumed. कहाँ पे concentrate कर सकते हैं उसको? Can be assumed to be a point charge at the center. है ना?
Yes.
Yes. तो गॉस लॉ अप्लाई करो और बताओ क्या आ रहा है. ओके, ये कैविटी है, इसमें कोई है नहीं चार्ज. option C. Others. Yes, come on. What about others? Okay, let's apply Gauss law. ओके क्यों नेट एनक्लोज्ड फील्ड निकालना है वो तो रेडियल है आउटवर्ड सो 4πr² बोल सकते हैं उसको now what is q net it is the charge density into volume now so what is the charge density total charge is q total volume is 4/3πr³. Okay, but you are scooping something. So how much of that has been scooped out? Okay, how much of that has been scooped out? एक मिनट यहाँ पे x लेना चाहिए, sorry, my bad. We should have taken this as x instead of r because r is a constant here. Okay, that's the radius of the scooped sphere. Okay, so this is the charge density and this should be multiplied by what? This should be multiplied by the volume of the annulus, okay, volume of the annulus, which will be 4/3π x cube मतलब पूरे sphere का volume minus r cube the scooped out volume. ठीक है 4π/3 gets cancelled 4/3π so you eventually get q by epsilon naught into bracket x cubed minus r cubed upon capital R cubed. And then okay, so this is not the final answer, by the way. This is e into 4πx², so e will be 1/4π∈0 x². अभी x³ minus r³ upon r³ तो एक ही ऑप्शन में है. Okay, so it is option C. Wait, what happened to 4π?
K is 1/4π epsilon.
अरे हाँ, उन्होंने k दिया है. हाँ, okay, yes, thank you. k 1/4π∈0. Got it. Okay, तो ये वाला पार्ट k हो जाएगा. Yeah, k³/x² into x³ minus r³. Correct. So option C is right. अच्छा, others who are not responding, please speak out because it's for your benefit, not my benefit. Okay. So raise your hands if you have understood this. Okay. Cool. Let's now go to 7th. A 4 microfarad capacitor and a 2.5 mega ohm resistance, ये micro है, ये mega है, 10⁶, are connected in series with a 12-volt battery. Find the time after which the potential difference across the capacitor is 3 times the potential difference across the resistor. Take ln2 as 0.693, 13.86, 6.93, 7 t. Now look, whenever time is involved, they want you to find the time. Okay, you have to understand that this is an unsteady state condition. Implying that di/dt is not going to be 0. प्लीज़ रेज योर हैंड्स इफ़ यू अंडरस्टैंड दैट. यहाँ पे स्टेडी स्टेट नहीं ले सकते, मतलब कैपेसिटर का अभी चार्जिंग चालू है. ओके फाइन. सो लेट्स ड्रॉ द फिगर. आर सी, यहाँ पे अल्टरनेटर नहीं है, 12 वोल्ट कॉमन है. ठीक है. ओके, लेट द करंट बी आई. Let the current be I. What will be loop rule? By loop rule. Okay, 12 minus IR minus Q by C. अभी मैं इसको C लेता हूँ, equal to 0. Now C, because C is equal to Q by V, V must be Q by C and it will be negative. ठीक है? This clear? Now we want di by dt because we want time dependence now. Okay, we want time dependence. This is at any given time. Okay, so we will differentiate this with respect to time. So 0 minus r di by dt minus I by c equal to 0. Have you understood this?
Yes, sir.
Take it. Take it. Great. Now we can integrate this. Let's take r di by dt to that side. Minus I by c is equal to r di by dt. I को यहाँ पे ले आओ. Minus 1 upon r c dt is equal to di by I. No, minus 1 upon r c is equal to di by. Okay. So ln I is equal to minus t by rc plus c1. I will be equal to, let's take a now, e raised to minus t by rc. Now what should be the value of a? Can anybody tell me?
Sir, that we can find from the initial condition.
Okay.
It's triple.
नहीं, इनिशियल कंडीशन मतलब t 0. Okay, at t
Yes.
equal to 0, what is the current?
Zero, sir.
Current is 0 initial. Wait.
So why would the current be zero at t equals zero? Because in capacitor, the current eventually declines. That means it starts from the highest value.
Correct. So it won't be 0. So let's keep it as it is. Let's keep the constant as it is. Okay, let's keep it as it is. Okay. Now tell me, what will be the potential difference across resistor? Okay. Potential difference across resistor will be IR. Okay, potential difference across resistor will be IR. So that will be R e to the power minus t by RC. Okay. Now, can you people tell me what will be the potential difference across capacitor as a function of time? कितना आएगा वो?
Sir, q naught times 1 minus e raised to negative t by rc divided by capacity. So q by c.
नो क्यू बाय सी तो फॉर्मूला है. अभी इसमें आगे कैसे करोगे?
Sir, we'll find it.
Integration.
Integration of what?
Current.
So we'll write q as q naught times 1 minus e raised to negative t over rc.
ऐसे?
Yes,
ओके, कैसे लिखा, कैसे निकाला ये?
For RC circuits, instantaneous charge across capacitor.
Okay, fine. Is he correct as far as this formula is concerned?
Yes, sir.
करेक्ट. ओके, तो क्यू नॉट नहीं पता है ना लेकिन.
Sir, we'll apply loop rule, sir, for finding the initial current.
एक मिनट, हाँ ठीक है, लूप रूल. अनदर व्हाट आर यू सेइंग?
So I'm saying Q naught is just another constant like
A.
in the previous equations
ओके,
value.
ठीक है. तो यहाँ पे ए नहीं आएगा. ओके, ठीक है. So we want delta VC to be 3 times delta VR. ये पूछा है ना. We want time at which the potential difference across the capacitor is 3 times the potential difference across the resistor.
Yes, sir.
ठीक,
Q
ओके.
naught will get cancelled.
नहीं, एक मिनट पहले लिखने तो दो. Q naught 1 minus e to the power negative t by RC is equal to 3 into R into e raised to minus t by RC. Simplify. Q naught minus Q naught e raised to minus t by RC is equal to 3R e raised to minus t by RC. ठीक है. अभी ये इसको वहाँ पे भेज दो. सो Q naught is equal to 3R plus Q naught e raised to minus t by RC. Therefore Q naught upon 3R plus Q naught, okay, is equal to this. Then minus t by RC is equal to ln Q naught upon 3R plus Q naught. T will be equal to RC ln 3R plus Q naught upon Q naught. Now my question is, how will you find Q naught?
dq by dt equals I. And
dq by dt equals I.
Q naught is a constant, so we can't differentiate that.
No, he is saying I को इंटीग्रेट करो, Q आएगा, फिर T को 0 डालो वहाँ पर.
So Q naught is
Yes.
the charge on capacitor at steady state. So we can simply
No, it's not steady state, it's initial condition, right?
No, so Q naught is the peak.
Oh yeah, peak charge,
So
correct.
that will be on steady state.
Okay. कितना लोगे फिर स्टेडी स्टेट वाला चार्ज? ट्वेल्व वोल्ट ही लेना पड़ेगा ना पोटेंशियल डिफरेंस का, राइट? Because under steady state no current flows, so capacitor, okay, fine. Q naught is C is equal to Q by V.
CV, sir.
CV, correct. Okay. ओके, तो ये 1 ही ले लेता हूँ मैं यहाँ पे, प्लस 3R बाय Q naught. ओके, नाउ लेट्स फाइंड एवरीथिंग. RC, ये म्यू है वो माइक्रो मेगा है, तो वो 2.5 इंटू 4 लिखा तो भी चलेगा. R is 2.5 into 10 raised to 6. Did did we miss that A part here? है ना, यहाँ पे A part नहीं आ रहा है, एम्पलीट्यूड नहीं आ रहा है करंट का. डेल्टा V इज इक्वल टू IR सही है. यहाँ ये A होना चाहिए यहाँ पे. वही बोल रहा हूँ, वो A को हम छोड़ नहीं सकते वैसे, है ना. So how will we find that? Tell me.
So we use the peak value of the current.
Peak value of the current. Okay. Okay.
Also, I think, can you scroll up once?
Yes.
No, little down. I think at one place you have multiplied. No, no.
No calculation, right? Okay. So how will we find? How will you find the peak current then?
So the
Ohm's
peak
law.
current is when the capacitor acts as a short circuit, so we know the resistance and
Correct.
the voltage.
Okay. (12 by 2.5 into 10 raised to 6). Okay. Fine. Okay, capacitor is 4. Capacitor is 4, so this will be 4 into 10 raised to minus. Okay. तो सबसे पहले हम वो एक्सप्रेशन का ये कर देंगे. 3 into 2.5 into 10 raised to 6 into A. 12 upon 2.5 into 10 raised to 6. Nice. 1 upon 4 into 10 raised to minus 6 into 12. Ooh, okay. 2.5 into 10 raised to minus 6 goes, 12 goes. So we are left with 1 plus 3 by 4 into 10 raised to 6 का ln. नहीं ये काफ़ी बड़ा हो रहा है. I'm still worried, I mean, a bit skeptical about using that formula directly here without considering the A part.
Sir,
Yes.
if you try and solve the initial part, you'll get in 13.5, and there is an option which says around 14.7 or 14.5.
Oh, which one? So you calculated the log here, is it?
The log this thing. So if you calculate it, you'll be getting 13.5 or 13.6. So there's an option for 13.8.
No, wait. 2.5 into 4 itself is 10. है ना? Right?
They just calculated the log value.
It will be much greater, I suppose.
Yes, so it's 135.
This is 13.52, but then 2.5 into 4, that is not 1, that is 10. है ना? So the answer that you will get is 13.52 into 10, and that doesn't fit. Just because the digits match doesn't necessarily mean that the answer should be that. कौन सा वाला?
integrating.
ये वाला?
It was yes sir.
इससे क्या
So
निकालोगे?
integrate and will what?
इससे चार्ज निकलेगा. That's what you think. दिस इज एन एक्सप्रेशन फॉर करंट. उसको इंटीग्रेट करके क्या निकालना चाहिए? क्या निकलेगा? चार्ज ही निकलेगा ना.
Yes sir, charge will
हाँ.
So but that is how you get the formula that we used in the first place. That was
Yes. So what? Okay. So what do you think you can do to solve the problem? Because the answers we got is not matching with the answer in the options.
Sir,
Hmm.
I tried directly using the formula v is equal to v naught 1 minus e to the power minus t by rc, and I've got 7.
You got 7. No, 7 is not right.
What is the official answer?
Official answer is A. Okay. मुझे यहाँ तक तो सब सही लग रहा है. इसके बाद जो आप लोगों ने वो फॉर्मूले बताए, पहले मैंने पूछा ए लेना है या नहीं, तो आप बोले कि वो ए नहीं लेना चाहिए यहाँ पे, है ना? Saying it is no need to take that A. ठीक है, एक काम करता हूँ. आप लोग ये ट्राई करो फिर से. मेरे पास सॉल्यूशन है. जो मेरा सॉल्यूशन है वो मैं आपको भेजता हूँ. ठीक है. अभी आपके पास दो ये है ऑब्जेक्टिव्स है. एक तो ये गलत क्यों आ रहा है वो ढूंढो, मैं बताऊँगा आपको. नहीं आया तो बताओ. ओके. सही आंसर 13.86 है अगर ln2 यूज़ किया तो. Now if they have given us ln2 as 0.693 in our expression or in our solution, ln2 कहीं ना कहीं तो आना ही चाहिए. Okay, and we don't see that coming here. Okay, we don't see that ln2 coming anywhere here. So देखो एक बार, नहीं आया तो मैं सॉल्यूशन एक 5-10 मिनट में भेजता हूँ. मेरे पास है वो सॉल्यूशन. ठीक है.
Okay.
हाँ.
Yes, sir.
Yeah, okay. ठीक है. We will also quickly discuss this MSQ rather. In the given circuit, the AC source has omega 100 radians per second. Considering the inductor and the capacitor to be ideal, मतलब कोई resistance नहीं है उनको, the correct choices are: current through the circuit is 0.3 amperes, the current through the circuit is 0.3 into root 2 amperes, the voltage across 100 ohm resistor is 10 root 2, the voltage across 50 ohm resistor is 10V. ठीक है. कैसे निकालोगे?
Loop rule sir.
इसको I1 बोलो, इसको I2 बोलो. ठीक है. दोनों पैरेलल है तो दोनों के अक्रॉस जो V है वो 20 ही है. ठीक है. साइन 100. Now can we find the amplitude of the current I1?
Yes sir. V equals IR, so 20 times resistance.
नहीं 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 नहीं.
I is equal to V over R.
V by Z.
Yes sir, impedance.
ओके. इम्पेडेंस
20
आएगा.
divided by 20 divided by
ओके. ये लीड करेगा या लैग करेगा? कैपेसिटर है यहाँ पे. सिविल याद रखो, CIVIL. ओके. First three letters for a circuit which has capacitor. Current is going to lead. Okay, I will lead.
So won't it be omega c the whole square instead of 1 over omega c the whole square?
No, how?
because aren't we dealing with an inductor?
नो मैं I1 की बात कर रहा हूँ. कैपेसिटर है ना, राइट है ना, वो चेक करके लो. ठीक है. कैन वी फाइंड cos phi or let's say phi 1? Yes, can we find this one?
Yes, sir.
What would it be?
R over.
बताओ. R over.
So we have to draw a triangle.
Yes, R over Z.
One of its side is R
ठीक
or
है.
1 over.
ठीक है, तो यहाँ पे phi 1 आ जाएगा. Now can we find I2 amplitude? Same, V by Z. V by root R squared plus omega L squared. Okay, तो इससे amplitude निकालो. Now for the second circuit, will it lead or lag? It will lag because VIL वाला part अभी consider करना है. Voltage comes first, so voltage leads current. So I lags V. Okay, I lags V by how much amount? Cos phi 2. R over Z. Let's call it Z1 rather. ठीक है. तो अगर हमने ये वोल्टेज ले लिया, वोल्टेज फेजर लिया, तो I2 लैग करेगा, है ना. दिस विल बी phi 2 एंड I1 विल लीड. ओके, तो I1 और I2 के बीच जो एंगल है वो है phi 1 plus phi 2. So please find that out and add to find the net current, use vector addition. Okay, please use vector addition there. Use parallelogram law. ठीक है. And once you get I1, you can also find out the voltage across the 100 ohm resistor and voltage across 50 ohm resistor. एक बार करंट आ गया तो वो निकल जाएगा. ठीक है. सो आई एम लीविंग दिस टू यू एज होमवर्क. आएगा ना या नहीं आएगा?
आ जाएगा सर.
ठीक है. ये किसी ने ट्राई किया? दिस इज फ्रॉम नेस्ट 21 शिफ्ट 2. करो ट्राई. इसमें ये तो आपको पक्का आएगा सी और डी प्रूव करने में. ये तो ये प्रूव करो, ए और बी का देखेंगे. ठीक है.
सर डूएबल सर.
डुएबल है तो बी और ए का भी करो. नहीं आया तो कल देखेंगे. ठीक है. Cool. So we'll stop here for today. Tomorrow we don't have a class. On आज कौन सा है? आज Wednesday है. Yes, today is Wednesday. So on Friday we will take maths, probability, statistics and I think उसके साथ matrices है. हाँ ठीक है, उसका लेंगे. Cool. So I have touched all topics from electromagnetism, right from electrostatics, current, electricity, moving charges, magnetism, AC circuits and electromagnetic induction. So that's it from my side for today. इसका सॉल्यूशन अभी मैं भेजूँगा आपको, वो एक बार देख लेना. किसका? वो जो DC में था ना, कैपेसिटर का चार्जिंग 13.86 का. ये ठीक है. Fine. See you on. Yes.
So the mechanics problems that you had shared.
Yes. Sorry, I didn't reply you yesterday. I'll do it today. Right now I'll do it. ठीक है?
Okay, sir.